joining me. My name is Krysta and I'm an educator with Discovery Place. Today I'm at Discovery Place Kids in Huntersville because I'm learning about the science of sound. Now if we're going to talk about sound, the first thing we have to figure out is what causes it. How does a sound start? Sound is begun by vibrations. Vibrations are little tiny movements in the particles around us. So the vibrations travel through the air. The easiest way to feel this is to put your hand on your throat. When you're quiet, you don't feel anything moving. Now say, science is cool. Do you feel the vibrations in there? As the air passes your vocal folds, it's causing it to vibrate and sound is coming out. I've got a handy tool here to help us take a closer look at what these vibrations look like. When the tuning fork stays still, it isn't vibrating, so no sound is being produced. But when I strike it and it starts vibrating, that's when we get the sound. Now you can really see how much it's vibrating when I strike it and then put it in this glass of water. So now we know what causes sound, but how is the sound of this tuning fork here reaching you all the way out there? Well, like we saw in the water, sound creates vibrations which create waves, but these waves don't just travel through the water, they also travel through the air. Sound waves are longitudinal, which means that instead of moving up and down, they move closer and further apart. Now they're doing this through the air molecules that are around us all the time. So a sound wave moves air molecules further apart and closer together, and this travels long distance through the air. I've got a slinky that's going to help us take a closer look. Let's say that my hand on the left is the tuning fork, and the slinky is the air molecules around it. The tuning fork is going to vibrate and push these molecules closer together and further apart. A sound that has a higher frequency is going to have faster vibrations. It'll sound more high-pitched. A sound that has slower vibrations is going to have a lower frequency and a lower pitch. Alright, let's experiment a little bit with high frequency and low frequency sounds. Now, these instruments here are called boom whackers. Each boom whacker has its own frequency that it vibrates at. You listen and tell me which one has a higher frequency and which one has a lower frequency. This one was higher and this one was lower. What do you think is causing the difference between these two frequencies? Do you see anything that's different about them? I'll give you a hint. The sound isn't caused by the color. It's the length. This one is shorter, so it vibrates faster and has a higher frequency. This one's longer, so it vibrates slower and gives off a lower frequency. So how do we hear sounds that are traveling through air molecules around us? When sound waves move through the air and reach our ear, they get funneled down into this tube right here called the ear canal. At the end of it, they bump up against the eardrum right here. These vibrations cause a chain reaction all the way into the cochlea. From there, nerve endings send a message to your brain telling you what you've heard. Your brain is the one that says, hey, I love this song, or maybe dinner's ready. For people who are deaf or partially deaf, this process is interrupted at some point. But sound waves travel through objects as well as air. So sometimes people who are deaf or partially deaf can feel vibrations through the ground or through other objects around them with their hands or their feet. Now that we've learned about all these frequencies, let's put them together and see what we get. Now that we've learned about the science of sound, let's put these frequencies together and see what we get. You can make your own versions of boom whackers at home. Here I've used some cardboard tubes. You can also use PVC pipes. So these right here, this one is a tube from a roll of wrapping paper. This one is from paper towels, and this one is from toilet paper. Try these out at home and see how they sound. Do they